So let me share my other set of screens. So yeah, last time I was yes, question. What's happening? One more time. Oh, it's my great ball. Yes, I'm a Pokemon fan, at least for the first couple generations. Alright, so I should be mirroring my iPad, so then I can actually write some math. So here, yeah, question. You press annotate, okay? I may need to pause your annotations, okay? But make sure you can find that. I'll enable it at certain points for you to write and do some work, but otherwise I will not. So if you're on shared screen, you have to kind of scroll to the center and then let the menu like drop down, okay? Connor, did you find it? So while we're sharing screen, like, ooh, you see it? So go to the center towards the top, the top of your actual screen, and then you should see mute, stop video, manage participants, annotate, so on and so forth. Do you see annotate? It's a pencil. All right, then I can't help you out much. Sorry. All right, so I disabled your annotations. Yes, but not right now. So right now I disabled them, so I can go over some math. So up here, okay, let's go over, where is it? This one, okay. So on this thing, okay, wait, do you see? Right, so you should see like something like our textbook. You should see the work that's on there. Yes? You may see two Mr. Chans, because yesterday while I was recording, I wanted my face to be in the lower right-hand corner, so you might get two Mr. Chans that are mirrored. Something you have to deal with. Okay. Enterprise. Okay, so I think this addresses your question. So you should see a red dot on the screen. I can't see my red dot right now. Is it lagging? So right now, do you see, does it lag a little bit? Okay, so yeah. So let me, I'm not sure about the delay. So give me some feedback while I try out this problem, okay? So down here, as I scroll down a little bit, so if we were in class, we'd go through the situation, the settings, kind of like we are quality control workers in this parabola generating factory, and we give people equations. So I'm just going to focus on the math part of it. Let's say you wanted a parabola. You wanted specifically an equation of a parabola that passes through these specific points. Okay? And notice in this problem, both of these are x-intercepts. So if I were to sketch my parabola, here's my x and y axes. It would look like something like over here is -6, here is 1. Make my pen a bit thinner. Okay, so far so good? Gosh, it is really, really slow. So, knowing just these 2 points though, we're kind of unsure, like, does it bend upwards like this? Right? Could it look like this tiny or this wide parabola going down like that? Okay, 2 points right now aren't really enough, okay, to get a single equation, and I'll show you why. Okay, so for now, for simplicity, maybe we want to graph a parabola that points upwards like this, okay? And then we go back to one of the forms of a quadratic. Y equals ax squared plus bx plus c. Okay, anybody remember what this form is called? Yeah. This is standard. Yeah, this is standard form. So you're very close. Okay, in this chapter we go over like 3 forms of a quadratic. factored form, this is what we worked with a lot. It looks like y equals, well, yeah, sometimes there's an a, then it's x plus something, and then x plus something else. Okay, that's factored form. And then the newest form that we're playing around with looks like a times x minus h squared plus k. And that's what Frankie mentioned being a vertex form. Okay, this is vertex form. So because this one is like the newest, this one may be the hardest for you. We need to make sense of what's going on, but this one is especially useful when we are graphing out forms of a quadratic, or focusing on the graph. Sometimes our textbook calls it graphing form. So like the quadratic formula or the vertex. Oh, Frankie, you've seen these ones before. You've seen standard form. Yeah, you've seen factored form. Yeah, you've seen those too. And then vertex form is the newer stuff, so I don't blame you if you haven't seen it before. But that's why we're going to get practice. Yes. All right, we'll continue on. So from the graph that I erased, maybe I'll draw it again over here, but small. Okay, there's -6, there's 1. So we're going to use factored form and kind of work backwards, since we already know the x-intercepts, right, over here and here, to figure out what this equation looks like. So notice, right, now, let's see, is that going to be the right equation? Because some of you did this in your homework as I was grading some of it. So if we go over like the zero product property, let me use a different color. Okay, notice right here, if you solve for x, when y equals 0, you get x is equal to -6, okay? And then these two together give you the correct x-intercept of -6, 0. Yeah, so far so good. But if you do so on this side, this is where a little mistake occurs, right? Same thing, solve for x, right? This is the zero product property. Y equals to 0. Notice now x actually equals -1. And you see that it doesn't match what we had up here. So what's the fix we have to do? Yes, very good, Tracy. So then we need to change this to be a minus, okay? And then this thing turns into a +1, giving the correct x-intercept of +1, 0. Okay, question so far? Okay, so I'm reviewing the chat. And so, Alexi, to answer your question quickly, for A, in that case, you would have to complete the square. So those, I think it's homework 20 in the notes in the back, or you can Google that, look on Khan Academy. Complete the square is how you get from standard form to something, and solve for a specific A value. And there's a bit more algebra involved. We'll cover that in the coming weeks. Okay. Yes, question. Yes. So if you are turning in homework, try to take a picture of it, like with your phone, and just email it to me. Yep, that would be the easiest way. Nothing's counted late during the session. I'll just give you full credit for showing me the amount of work that you tried it. Okay? Whenever school starts up again, till we get official word. So homework. So there's nothing, like everything I'm assigning right now is all optional. Homework, like up to 20.5, get it in when you can. The due date was on the 20th. So that's when I expected it. Most of you turned in some kind of work in your folders, and I'm working through that. But otherwise, just get it in when you can over this extended break. So if school doesn't start again, then as soon as I get the word from the school district or a principal that I can start covering actual like math content, then that's when due dates are going to be set, and I'll be lax with some of them. Like I'll give you more wiggle room, I'll be more lenient with my deadlines because we're still adjusting to this online learning environment. What if there's problems we don't get? Then, if you have problems that you don't understand, I'm pretty much sitting in front of my computer all day. So message me, send me an email, and then I'll reply in like 10-15 minutes with something to help you. Or we could set up a smaller session either in Discord or in Zoom or in Google Meets, and then I'll walk you through the problem and you can show me some of your work and we can emulate the like one-on-one tutoring. Okay, let me just double check the chat to make sure I got most of the questions. Okay, so returning back to what's on my screen, so you should see like when we have x-intercepts, it becomes kind of easy to figure out what the parabola graph is, okay? So then notice you have this a value out here, okay? That thing kind of is the hardest part about this chapter, in my opinion, because this a value is like a multiplier. When you're graphing parabolas, the a value affects like how wide your parabola opens, like this or like that, okay? Depends on this a value. It's the same a value as this one out here, this one, and this one, okay? So it determines this like wideness and also determines how like does the parabola open upwards or open downwards. So then down here, this a value, a is negative. So it was a minor point that we studied like way in the beginning of the school year together in the fall. We noticed that parabola is something squared. They pointed upwards. These things, a value is positive. And it's that multiplier that kind of messes up our equation, because if we scroll up, you can see that this person, right, says that I tried to order a parabola that passed through these points, only to have you send me the wrong one. Okay, tell me how to order the correct parabola. And then in this like kind of situation, we tell them like, oh, person, your equation, you didn't give us enough information, right? If we were out in the working world doing quality assurance, you only gave us 2 points. As I mentioned in class, like before we went on break, you need at least 3 points to get a specific parabola, and you can see why now. It's because of this a value. Okay, because lots of parabolas could have the same x-intercepts, but then look wildly different, as I drew in the beginning. So the simplest case is, okay, you would tell the person to enter in a specific, like give me a third point, or tell me what you want your a value to be when you do a for a equals 1. That's like the easiest case. Then you have this equation in factored form. If you multiply this out, either with FOIL or your boxes, then you get x squared plus 5x minus 6. And that's standard form. And that's pretty much all the problem asked of us. Okay, so far so good. Any questions about this first problem? No? Okay, so I'm going to scroll down. This is where it gets a bit more complicated. So parabola that hits the x-axis just once, okay? We're lucky still. It's still an x-intercept. That's nice. So then we could probably use factored form since we know one of the x-intercepts. But now, since your parabola hits the x-axis just once, at 5, let's call this 5, it could still open up like this, going downwards, or like going upwards like that. Okay. And then we can change the wideness. We can say, okay, maybe they wanted this specific parabola like that if we wanted to mess with a values. So then you think, okay, if my equation looks like factored form, if it hits the parabola or hits the x-axis just once, I need it to be positive 5 to be the answer, or the x-intercept. It looks like this. But notice, right, you got two of those that end up being the same number. Okay, so that looks like for a equals 1, y equals x minus 5 squared. And then if you FOIL that out, if you distribute that, you get this fancy equation. Okay. So again, if we go back to the top, we see that, oh, this person wanted to, like, was dissatisfied with their order, assured me that meet my needs no matter what. How do I order my special parabola? You have to tell me, does it point upwards or point downwards? Because it could look like for a equals -1, y equals negative x minus 5 squared, y equals negative x plus 10x minus 25. That could be another valid equation. And then because of all these a values, you can see why we made the mistake in the order. How wide do you want your parabola? And that gives you a bunch more different equations. Cool. Okay, third equation, maybe something like this, is more towards the student's question that asked me, how do you come up with equations? Right, I'm trying to find the question. So how do you equations the parabolas, right? You're given some kind of graph, and now can we piece together what we know to get an equation out of this? Let me zoom up a little bit. You may want to take like this graph right here, keep that in your memory. I'm going to scroll up a little bit to bring down the forms of a quadratic, like standard form, factored form, and vertex form, because we're going to use those three equations to help us out. Give you a moment to do that. Okay. Also, don't feel like stressed to get everything down. When I started talking about math, I recorded part of it, or I'm recording most of this, so it's going to be posted to YouTube, so you can slow it down and use it at your own pace. Okay, and how about a copy? So bring this stuff down over here. Where should I put it? Maybe right there. Okay. Maybe in blue. So then, what should we do? Let's annotate a little bit. So over here, right, this thing, your C value is your y-intercept. We went over the A value of these things. Okay, that's the wideness of your parabola. B doesn't have a real measure for just standard form. And then over here, I guess I left off that h comma k is your vertex. So h is the x-coordinate of your vertex. Okay, this h, notice, is being subtracted from x. Just like when we want a positive x-intercept, we have to take it away. And then down here, this is k, that's your y-coordinate of your vertex. Okay, that's different than the y-intercept, which is c over here. All right, and we're going to put some of those into play. If you notice in this parabola, it looks like we have one x-intercept at +2. And if we zoom in over here, it looks like our second x-intercept is -3. Okay, so building on what we know from the first problems, we have 2, 0 and -3, 0 as x-intercepts. Now we're going to go to factored form, okay, because we know our x-intercepts. That's the form that allows us to most easily come up with an equation. Let's put those in. Y equals a times x plus, no, -2, and then x plus 3. And now, in this problem, we have more information, okay, because they gave us this part. Looks like we have a y-intercept of 6 to solve and figure out what this equation looks like. We can solve for this a value. And then notice, I think we have, well, we don't know for sure based on the picture, okay? If we have our vertex, looks like it's between -1 and 0, but that may not be super precise, but we can write that down. Y int at 0 for the x, +6 for the y. That might come in handy. So, questions so far on how we set that up? It's very similar to the first 3 problems. Nope. Okay. So then notice, for this equation, right, for a y-intercept, these are x and y values. Okay? And if this is our equation, we have one equation with 1, 2, 3 variables in it. We're looking for a. Looking for a. That's the wideness, or like the stretch factor of a parabola. That's how we narrow down and get a very specific equation. Okay, any ideas on what we do at this point to solve for a, knowing what we know? Here, I'll enable annotation so you can try to punch stuff in. Okay, you can just scribble on the screen at this point on what else to do. Go away. Any takers? Any ideas? Oh, I was wondering if you were talking because there was a window by it. That's why I was unsure, because I was hoping you would participate. Oh, well darn. I'm trying to solve for a in this equation that I underlined in blue. No? No takers? Victor can solve this. Go, Victor. That's what Raymond says. Okay. No. No. Okay. Alright, so... Okay, so Melinda, would you like to chime in? Right, can like either of you draw it on the screen? We're practicing how to participate on an online classroom. Okay. IDK, alright. So at this point, notice we have one equation, okay, and this is the part where we use our y-intercept, but that's not the only way to go about solving this problem. But right now, I think that might be the easiest way, okay? So, if we know that our y-coordinate is 6, okay, and we're looking for a, using the definition of a y-intercept, you know that this value is 0, and this other value for x is also 0. Okay? 6 equals a times -2 times +3. 6 equals a times -6. What does a have to be? Yeah, -1. So now we have the parts of our equation. Y equals -1 times our factored form -2 and then +3. We can rewrite this. Y equals -1 times x squared plus x minus 6. So then our final equation is -x squared minus x plus 6. Okay, all these answers would work. Why is this so complicated? So it becomes complicated because there's lots of steps involved now. You are mathematically mature enough to handle some of this. And if you don't think so, then it's my job these next couple months to convince you that you are. So like in the beginning of the chapter, we focused on just factoring. That's the skill. And now we're applying those skills in different ways, thinking about the connections between graphs, tables, words, like all these equations, and what parabolas look like. So it may feel weird because so far we haven't, well, we kind of talked about word problems like the water balloon task, or what was that other one? Like a roller coaster or some other kind of like arc movements. That's where parabolas appear in the real world. So we're getting there. How to use vertex form. So in this case, if we know our vertex, right, in this problem it was hard to estimate that right here, okay? If we know that, then we have our equation pretty much. If we have our vertex and one other point, then we can get a specific parabola. If I scroll up a little bit to, well, maybe it's not here. Yeah, it's in a different classwork. Let's say, if you, like, typically you'll be given something in standard form. You can figure out the vertex either by completing the square or using the like shortcut to get the x-coordinate of the vertex, and then use graphing form or use this thing. In a word problem, if you know the minimum or maximum when we encounter those, then you would probably use the vertex form, okay? Because that'll save you save you some work. But we haven't really encountered that just yet. If I go back in this classwork, not now, okay, in this messy thing, over here is where we first encountered, oh, I don't understand. You gotta be more specific than that. In this classwork, we first encountered vertex form, but it was just kind of thrown at us. We haven't really played around with what to do with vertex form, like down here, over here. So we're just treating it like an equation right now. We haven't really worked backwards to make use of it. Okay. So right now we're just approaching it in a graphing context, not in a word problem just yet. Okay. When do we need to understand this by? Vertex form, often, like when you get to Algebra 2, your teachers are going to review it. For now, maybe Chapter 9, that's when you really have to know vertex form. If it was still normal school, I would not test you on, well, like the beginning part of vertex form, I would. Like if I tell you, like if I give you like this equation, and I'll tell you to graph it, you should be able to identify where the vertex is, okay, and then sketch a graph based on that kind of equation. I won't give you something like like this one, I won't give you something like this and then tell you to graph it, well, and then tell you to convert it to vertex form, like with algebra. You could use a graph, like that works. I prefer it like this down here. Okay, that's something you might see if we were still in school and I gave you a normal chapter 8 test. You were to graph it, but probably like one problem to graph and sketch. Same. You mean? Okay, I don't quite understand. It might help if you just told me instead. So that's the extent we need to know for you haven't made a vertex form equation, right? What's your opinion on The Weeknd's new album? I don't know. I haven't made a vertex form equation. You're right. If I go back to my original work over here, let me pause annotations for a bit. Okay. Can you make one what? What do you want? Person in gray. The equation in vertex form? Yes, okay. Let me pause. Okay, so type in the chat window. I'm going to clear these annotations. I figure it out. Go. Okay. All right. So down here, okay. Let's see. Let me think. So, like, let's say from this point, okay, I have factored form, I have standard form for an equation, and now I want to get to vertex form. If you looked at my previous stuff, there's a short little equation that helps us solve for the x coordinate of the vertex. This little equation comes from the idea that when you have, well, I can just demonstrate with this parabola. When you have a parabola like this, okay, from positive 2 to negative 3, okay, how many spaces is that? 2 to negative 3. What's the distance between those, like these two x values? Yeah, it's 5. So you go like 5 over, right? The total distance here is 5. Making use of symmetry, half of 5 is 2.5. So then right here, right, 2.5, okay? Right here is called your axis of symmetry, okay? And that's always going to be where your vertex is. If you think about like the water balloon task, when you toss a ball, it goes up, it hits its maximum right about here, and then it falls down. So that's a special property of a parabola, and we're using that because knowing that the vertex, right, either the minimum or the maximum, like we have in this case, this is a maximum, okay, because that's the biggest value. It's always halfway between your x-intercepts. That's what this equation pretty much does for us. It figures out what's halfway between those values. So notice, like for this equation, a equals -1, b equals -1. You have +1 over -2. Okay, so that's a negative of a negative, like that. We have -1/2. And you can see, yes, that matches my picture, right? If you start at -3 and go 2.5 spaces over, you end up at -1/2. And then from there, you can plug it in to this general form, right? Y equals a x minus h squared plus k. Okay, k is the y coordinate of your vertex, not the y-intercept. So we can start plugging in values. We don't know y yet. We do know our a value is -1. We know your x coordinate is minus a -1/2 squared plus k. So at this point, if we were to convert this into vertex form, now we got to solve for k. Okay, so then here, solve for k. And at this point, you can use like any of the values you want. You can use your x-intercepts here, here. You could use your y-intercept. I think like I don't think it's a smart move to use your vertex because it doesn't give you any new information. Maybe it does. So then it's a little bit more algebra at this point, and as soon as I'm done with this problem, I'll pause. Like, that's all I'll cover for today. This stuff, remember, you don't have to know until maybe like a month or like 3 weeks from now, but for those that asked, for those that are curious, I'm just going over it now. Okay, so let's use our y-intercept. So that becomes positive, use y-intercept of 0, 6, 1/2 squared plus k. 6 equals -1 times 1/4 plus k. 6 equals -1/4 k. Add 1/4 to both sides. K is equal to 6 and 1/4. So that means for vertex form, our equation looks like y equals -1, x minus a -1/2 squared plus 6 and 1/4. So it's a little messy, but that's our vertex form. I always seem to leave off in a parentheses. Okay, so this is, we'll get there. Most of this, well, do we go over this? We kind of go over it, but they're easier cases for going from standard form to vertex form. So yeah, and then you'll see it again in Algebra 2 for sure. So if you don't get it during Algebra 1, you'll see it again, and by that point you will hopefully understand it better. Okay. If you want to get more practice, you would Google or look at Khan Academy vertex form for a parabola. Completing the square will come up eventually in there when you look at vertex form. Okay, that's all. I'm gonna post this notes up to on Piazza and also upload whatever I recorded after some light editing onto YouTube. Okay. Where is this thing?